Okay, so we've got a lift pulled upwards by means of a vertical cable, and initially the lift's at rest. It then accelerates, okay, till it reaches a maximum speed, and then it moves at this maximum speed before decelerating uniformly to rest. Okay, and then the total mass of the lift and its contents is 360 kilograms. So you can see I put the weight here, 360 times g, gravity. That gives you the weight, mass times g. And you notice then I've split this up into 3 stages, okay, because there is a first stage where it accelerates from rest, okay, and then it reaches its maximum speed. Of course, we must remember when it hits its max speed, then it goes at that max speed so that it stays at that max speed, okay, it doesn't increase anymore, so that means the acceleration is going to be 0 for that stage, okay, so it stays at its max speed, and then eventually then it starts to slow down, decelerates. So you see then I've still got my acceleration going upwards because the lift is going upwards, so I put my acceleration in the direction of motion of that lift, but I put then of course -3 to show that it's actually decelerating. So in part A then it says calculate the tension in the lift cable. So in part 1 then of part A, when the lift is decelerating. So we're interested in the third stage, okay, so if we use Newton's second law, again, you know, in the direction of motion, right, we always go in the direction of motion. So in the direction of motion, the forward force, because this is going upwards, the forward force is the tension, and of course you take away then the resistance of it, the weight, which is going the other way, 360 g, and that will equal then the mass, which is 360 times the acceleration, which happens to be -3 because it's decelerating. So if we work that out, okay, 360 times 9.8 of course, and then 360 times 3 will be 1080 or -1080, and then to get t you just take that over the other side, that calculation, and then you've got your answer. So it'll be 360 times 9.8, which is 3528, take away 1080, and you get 2448 newtons, okay, as your tension while this is decelerating. 2 then, when the lift, find the tension in the cable when the lift is moving at its maximum speed. So in each stage the tension is going to be different in the cable, okay, it's not going to be the same in each stage. In the second stage it's maximum speed, and of course for maximum speed it stays at its max speed, okay, so it stays at its max speed, which means the acceleration is 0, it's not accelerating, it's going at the same speed. So acceleration is 0, so if we use Newton's second law again, quite simply, it's going up, we'll have t, take away 360 g, but that will equal to mass times acceleration. Of course the mass is 360, but the acceleration is 0, isn't it? So quite simply, t will equal to 360 g, or 360 times 9.8, which we worked out before to be 3,528 newtons. Okay, part B then, it says find the magnitude of the acceleration of the lift, right? And we've got the situation given to us here, haven't we? Okay, so when it's accelerating here, we want to work this out, okay? But it does tell us something, doesn't it? There's a crate on the floor of the lift, and it has a mass of 25 kilograms. When the lift is accelerating, the reaction between the crate and the floor of the lift is 280 newtons, okay? So now what we're going to do is we can sort of ignore this diagram and we can draw a new diagram and focus in on this mass. Okay, so if we just draw the lift here, the mass inside, it says, it's got a mass of 25 kilograms, so its weight will be 25 g, and it says this reaction is 280 newtons. Okay, so we expected then to work out the acceleration of the lift. Okay, so because it's going upwards, okay, using Newton's second law, upwards, so 280 is taking us upwards, take away then 25 g, and that will equal to the mass. Now remember, we're focusing on the object alone, so the mass will be 25 times then the acceleration. So change that to be 9.8. Just calculate that. and we get 35. So 35 equals 25a, which implies then that a is 35 divided by 25, which will equal to 7 over 5, which is 1.4, okay, meters per second squared, of course. Okay, so we've got our acceleration there.